right, how are we doing, everybody? How's everything going? I'm gonna go ahead and roll out the music here. There we go. So I have some fun stuff today. So we're gonna be testing out a new mobile setup using an old phone I actually have here. To actually show this. So I was gonna just go fix this and see what's going on, but I did want to cover some stuff about the printer, and I thought that maybe the issue would have been give me one second, I'm just double checking my settings here. All right, so I originally thought the issue was related to an actual problem with the Hotend. Now if I pull up my logs here from Octoprint, and I'll pull up the screenshots. So let me switch over here to the TV. And let me pull up my screenshot I took before I reset Octoprint. So I came in this morning and I was greeted with this offline thermal runaway system stopped heater underscore ID 0. So this is an issue with the Hotend. So you can see here, the printer's firmware triggered a thermal runaway because it detected an issue with the Hotend and then halted it. Now the nice thing is if you have Octoprint running, it does keep a log of the last 300 lines here. And if you have serial logging enabled, it'll keep everything. So I decided to pull the logs, and you can see here's the moves. And if we look, we scroll down, we'll see temperature. Okay, so we've got here the Hotend target temp, or the target, the Hotend actual temperature and the target temperature. So you can see I was calling for 245C, and it's hovering around 240, and the bed is on temp, so it's not the bed. If it was the bed, it would have triggered a different error. But you can see the bed was being regulated correctly, and these numbers here indicate the percentage of how much the MOSFET is being turned on, either a full state or half or whatever. So, and these 127 is full blast. So you can see here the Hotend was being commanded to heat, and one of the things that is affecting this machine is I updated the firmware, forgot to do a PID tune, and in addition to that, at some point the silicone sock was removed from this printer. So if I scroll down and see, we can look for another temp line, because it'll report every 2 seconds. So you can see the bed's still within target. This is still not within the 245C temp range, and you want to see your Hotend within 2C, so this is still out of the range. So right now Thermal Runaway is watching this and going, okay, something's not right here. I've been telling it to heat, and you can see here it bumped up how much power it was giving to the Hotend. And if we scroll down further, you can see another one here. We're still hovering right just under 240, and now it's at full blast. So 127 is full blast, and I don't know if there's another one. There is here. So you can see it's just not getting up to temp. So even at 127, now here's the thing, the heater cartridge on this, I already tested the resistance on it. The heater cartridge is good, and moved around the wires, not seeing anything indicating that there's a short anywhere or an open connection. And you can see right here, it now exceeded the allowable time to get up to the target temperature, and it killed it. Now between this is probably about 1 second between that Runaway and this. So we got 1 second here. There's 2 more here. So there's a total of 3 there. So we got 3 seconds, and then the other one is 5, and then this one will be 7. So this was telling it to heat for a while, and what happens is I do run my layer fan on this ABS machine at about 40% speed, and it's a very powerful fan. So not having a good PID tune on here, because I updated the firmware and cleared the EEPROM that wipes out the PID for that machine, in conjunction with the layer fan and not having a sock on the heater block, made it so it was having a hard time maintaining temperature, And it's likely if I had logging enabled for a longer period of time, we would have seen that the hot end temperature started dropping shortly after the layer fan kicked on and just kept slowly dropping. And because the PID wasn't tuned for that specific hot end setup, what happened was it eventually got to full blast like you see there, but it already exceeded the amount of time that's allowed to get up to temperature, and then thermal runaway triggered. So I'm going to try to use my little mobile setup here. I dug out my old V20, and I have a nice little app here that is going to set up an RTSP feed. And hopefully my gimbal's charging up here. So this is the first time using this. So we'll see how this does. Got to put this beast of a phone into the mount here, because this has the 0 lemon battery on it. This was my old main phone for a while. So let me switch over to my main here. And how this gimbal works is you hold it in place and you turn it on, and then you press and hold the button here. It should engage. Oh, nope, it is freaking out. Let's see here. Try this again. Oh, it might help if this was level in the box here. All right, one more time. It is not happy. The battery must be too low. This was sitting in a drawer, so I'm going to let this charge, and we're just going to shoot this by hand. You guys don't get the fancy gimbal. It does work on here. This has just been sitting in a drawer for a little bit. So, all right, let's see if I can switch over to my V20 here. Oh, it's not doing it. Let me see if I can restart the source here. Restart active playback. Active playback. Oh, look at that. Oh, look at that. You got a little bit of distortion, but we're going to see how this works. Got a little bit of distortion, but we're going to see how this works. So I'm going to mute the mic. You guys are probably hearing me through the phone as well. Disable the Yeti. So let me disable the Yeti. All right, let's see how this works. I'm going to put my preview up. Let's see how this works. I'm going to put my preview up here. I can actually see if it's getting a good feed. So I can actually see if it's getting a good feed. So this is going over my 5 gigahertz Wi-Fi. So let's see here. All right, can you guys hear me? All right, can you guys hear me? Okay, I didn't mute the Yeti. All right, we should just be going over the V20 now. I'm going to throw chat up, so you guys can't see me, but I'm going to throw chat up on the TV so I can see it. All right, so can you guys hear me all right through the microphone on the phone? Can you guys hear me okay on here? It's not going to be as nice as the Yeti, so, but it should be coming through halfway decent. I do have noise suppression enabled. It's going to get loud anyways when I turn this machine on, so what we're going to do here is, I already have, you can see here, this has been worked on quite a few times. This is my oldest machine. This actually started out as my ANET. Oh, there goes a, oh. I'll have to fish those out. That was a print falling down. So this started out as an ANET A8, and this does have dual extrusion capabilities, but you can see I'm only running it in single mode. But it has been worked on. It has been worked on quite a bit. So you can see I've replaced thermistors, the heater cartridge, that kind of stuff. So that's why this looks like this. It's not super pretty. But what I'm going to do now is I'm going to tell this to preheat, and this is running an ATX power supply. That's how old this thing is. But I'm going to tell it to preheat the hot end, and what I'm going to do is move around the cabling and see if I notice anything, you know, sparking, or if I move it to a certain side, it then stops heating. I'm going to turn the bed off because otherwise it's going to get really hot in here. So I'm messing with the LCD right now. And I'm just turning the bed off. And what I'm going to do is mess around with all the wiring here. So you can see here I have my head moved up so I actually have some room to work. And what I want to see is when I'm moving all my wiring, am I getting any changes in my hot end reading? And I'm not at all. So there's no changes there. Let me see if I mess with my thermistor here. No changes. We're still steadily approaching temp. If I move my heater wires here, still approaching temp. These feel solid. They're not like flexed off. You can see here I got them all tied up so they can't move that much anyways. Let's see, here's another. Alright, so I'm not seeing anything here that indicates that there's actually a problem with the heater block on here. So I'm going to let this get up to temp, and I'm going to clean the block, because if we look at the block here, let me take this out of the case. If we look at the block here, it's pretty dirty. So, come on, autofocus, there we go. So I'm going to gently clean that off with a wire brush and stay away from this side so I don't accidentally short my thermistor input. So let me get a wire brush here so I can clean this up. And I'm going to move this up even further here, so I'm going to prepare, move axis, or axis, whatever you say it, and move Z, not Z, move Z. And I'm going to move the carriage up. The funny thing is, all this noise is coming from this one fan here. I don't even know how old that fan is. It's a 30 millimeter, so I actually don't even carry that size right now. You see here we're moving up. And hopefully, oh, we're gonna bottom out here. Oh wow, look at that. Perfect. All right, so I'm gonna look at my thermals here. We're still at, let's see. We're still at 240, so that's good. It hit the target temp, but we don't have anything going on. We don't got filament going through this. We don't have, you know, my layer fan on at all. We just have it heating, and it's maintaining temperature pretty good. It's fluctuating about 1 degree. So I'm going to clean this off, and then we're going to do a silicone sock on here, and then we're going to PID tune the hot end. So when you're cleaning your hot end, stay away from this side, because if these bristles touch the heater wires and get up in there and touch your thermistor, your board's going to get fried. So just go back and forth. Don't press too hard. And then I'll usually try to get up a little bit in here and just get everything I can off the block. that's pretty clean now. You can see that. Why will your board get fried? Because you're going to send the 12 or 24 volts, whatever's coming in on the heater lines, into your thermistor input and either short to ground or you're going to short to the I/O pin. And the boards don't like that. They'll stop working. So these are the silicone socks we carry. We carry these for these style V6s where they have the glass thermistors, which is like what our tough Hotends use. We also carry them for Volcano style blocks and the Creality ones. So these we have in our shop. The photo's white. We have white and blue. Depends on what our supplier has in stock. But these are great because you literally just take them and put them up on the block like so. And you can do this while it's cold. But you can see here just a little tip of the nozzles poking through. So what this is going to do is help maintain stable temperatures and insulate the block from the air coming off your layer fan. So I'm going to let this settle out temp-wise because I want this sock to heat up. And the hot end's actually already back at temp. This is a 50 watt heater cartridge, so it's got some power to it. And what I'm going to do now is I'm going to go to prepare. I'm going to go back to prepare here. So menu screen, prepare, and we want to do cool down. And I'm going to let this drop down to about 100 C temp here. And to speed that up, even though we just insulated it, you can still get some help from the layer fan. So I'm going to go ahead and put my layer fan at 100%, which is 255. And I can feel the air coming off that. Oh, it sounds like this thing might be due for replacement. This fan is original. It's probably about 2 years old. And I wonder if there's just something in here. It sounds kind of weird. But it's still moving air. But 2 years in an ABS enclosure, I'm surprised this thing hasn't completely died yet. To be completely honest with you guys. So, to tune your hot end, I'm going to go back out to the menu so you guys can see. Now, if you're running our firmware and this is enabled by default, you can press your button. You can go to control, temperature. Now, this is running Marlin 119, so it might be in a different menu on 2.0. But you can see we have our P, I, and D values, okay? This is your hot end PID settings. This is Marlin default. But if I go here, I can do PID auto tune. And then I usually print about 245 because this only does ABS. So I'm going to set this to 245. You should set this close to your normal print temperature and then hit the button. Now what's going to happen is it looks like nothing's happening on screen. Okay, so but what is actually going to happen is right now it's doing cycling of the heater and seeing how long it takes to get to temperature. And it's going to figure out the P, I, and D values for the PID tuning, which regulates your hot end. So, and if you notice, I have my fan at 100% while it's doing this because you want to account for the layer fan cooling down the block. Now, the silicone sock does help a lot, but it's best to do a PID tune with your fan enabled on the layer because you want to account for this airflow this fan's going to be putting out that could be dropping the temperature on your block. Now, these silicone socks are really great for keeping the heat in and resisting being cooled down from the layer fan. We run the silicone socks on every machine here. So if you look here, here's all the crud that came off my hot end. So, and this has got one of our original Easy Flex sheets. Look at this, there's not even a tab on here. This thing has seen some wear and tear, but if you notice, I'm not even using the 220, this is a 235, but I've got so much room on this frame, it doesn't even matter. So, it doesn't matter, it doesn't have a lift tab because it's bigger than the bed. Now, I will show you guys here. I'm only going to put a little through because I don't want to mess with the PID tune. But you can see where the filament is exiting the nozzle right there, and you see the fan is blowing it. But the nozzle just pokes through. It just pokes through just a tiny little bit there to keep it safe from all the crud. So it's at 245. Now I'm going to switch back over to the Pi interface, and I'm pretty sure I have my Pi connected to this, and I'm going to show you guys the output and what it's doing. If it's not connected, then what I'll do is I'll show you guys how to do it with G-code commands and show you what it looks like when it's doing these tunings. So I'm going to walk back over to my desk here. All right, so I'm back at my desk. How was the video feed on that? Was it decent? I mean, that's a really old cell phone I was using. The camera on it's pretty good, which is why I kept it around. Let's see here. There's no easy way to insulate your block without a sock. You can try to rub RTV on it, but to be honest, it's not even worth it. So that phone I was using to stream is from 2016, September 6th. So, yeah, I don't like throwing stuff away. So let me connect into Octoprint here, and oh, look at that. Luckily, we are connected, so I can show you guys what this looks like. So you can see what it's doing here. So it's actually cycling here. Remember I told you about these values? So what it's doing is it's trying different amounts of power, and you can see here, our auto tune is finished. So these are the PID values for my particular Hotend setup and machine. And these will not work well for your machine. This is why you do an auto tune. So I can put this into my printer's configuration, okay? And I'll usually copy this, and you can put this into your config file, or you just write it down and you can set it with a G-code command. So I'm going to copy this just so I have this here, and I'll show you guys. I'll do it again, and we'll see how close the values are. So this is my first PID from LCD at 245C. Okay, so now if we go back here and I do an M503, it should automatically apply these to your printer EEPROM settings. So if we look here, an M503 basically spits out everything in your EEPROM settings. So M503 here, you can see all the different settings, my steps per millimeter, my feed rates, my acceleration. The reason my X and Y and Z are so high on this machine is because I'm running DRV 8825s. Those of you guys have been in printing for a while, you guys remember those. I still rock them on this machine. These are 1/32 stepping drivers, and these were out before the TMCs were even a thing. This is what we used, and they're fairly quiet. They're not perfect, but I digress. So what I can see here, let's see, can I switch back over? Let's see if my V20 comes back up easily. Let's see, it should reconnect. Are we going to reconnect? Hey, look at that, we reconnected. So that's nifty, so that works pretty reliably. I like that. But back to our EEPROM settings. So here we can see now we have an M301, and here's the new PID settings. So it automatically put these into my EEPROM. Now, I have to then do an M500 to save those to the EEPROM, because if I restart the printer right now, what's going to happen is it's just going to forget them, and we're going to be back at the default settings. So as I send an M500 here, we're going to get a setting stored, and it's going to spit out bytes and a CRC code for error checking. So you want to do an M500 after you do the PID. Hello. So yeah. So if you guys want to do the PID tune from your G-code commands, we actually have a full guide on our site here, which I always have to reference because I can never remember it. So, but basically you're going to connect to the printer. I'm already connected through Octoprint. That's where I have the terminal. So you can do this with printer face. S3D has its own G-code sender, but you just want to be able to connect to the serial connection of your printer. So we'll usually do 10 cycles, and M303 is the command to do a PID tune. E0 specifies the hotend. So if you have two hotends, E0 will be your first hotend and E1 will be your second. And I believe -1 is for your bed. You can actually PID tune your bed. Not that it's really needed. And then S255, this is the temp that it's going to PID tune and as the target. And then C10 is how many cycles. So if I go in here and paste this, and remember I said I usually print at 245, so I want to tune for 245. Before I send this command, I'm going to go here and yeah, you can see there, look at that. That's actually there's a camera mounted on the enclosure, and since the door is open, it's got a little wide angle on there. So I'm going to make sure the fan is at 100%. So I'm just going to turn it off and then back on. If I switch back over to the V20, you should be able to see that the hot end fan is spinning. So let me go back here, and now I know my fan's on at 100%. I'm going to go ahead and see our temperature, you can see, has dropped off. And you can see here the cycling that's occurring as it's doing the PID tune, and it's trying to get it more and more accurate. Basically, the goal is a flatter line. And if you guys are wondering why this looks so weird, you see here we got these really weird values and it's all over the place. This is because when it's in the ATX power off mode, the board is only getting power from the Pi, and it's not super stable. It's stable enough to run the board and keep it on, but the temperature fluctuates in terms of the readings. But once you power on the machine, you can see it's dead on. So I'm going to go ahead and execute this command. And all that LCD thing is doing is executing these command here. Does that firmware reboot when Octoprint connects to it? Yes. All your Marlin firmwares typically will reboot when you connect anything over serial, whether that's your computer or Octoprint or any other device that interfaces with serial. So, no, I did not block the 5-volt pin because I do want the board to stay on, because the board has to be on partially to turn on the ATX power supply. So back when 12-volt machines were the norm, a lot of people like myself, when we were building custom machines, because at this point, this is just a custom printer. The only thing from ANET left on that are the linear rods and the lead screws. But I want the board to be powered because there's actually a pin on the board, and that's MKS Gen 1.4, really old board, that can pull to ground or pull high. So the ATX PS on wire, which is the green wire traditionally on your ATX power connector, is connected to that pin, and Marlin has an option to control an ATX power supply. I hope I'm not getting sick. I've been coughing a lot lately, whether I've been vaping or not. But you can see here, so I issued the command, and if we go back up, you can see here, here's auto-tune start, and now it's ramping the heater up. So 127 is full blast, and we're going to see it starting to get up to the target temp here, which is going up pretty fast. ATX is a form factor of power supplies and connector type. I actually have, you can use like it's a computer power supply. And the one that's actually on this one is the same one that's on my custom CR10 over there. And it is a server power supply. It's a 500 watt server power supply from One U server. So it's only about this tall, by about this long, by this wide. And you cut off all the connectors and do that. I haven't done an ATX power supply on a printer in a long time. I've been sticking with the Meanwells, but this machine, my little purple and black one that's up on top there, and my CR10 all have ATX power supplies on them because that's what I was doing at the time. So if we're looking at the output here, you see it's going to start spitting out some data. And you can see it got up to temp, and then it just said, okay, let's see what happens when we give it no power and how quickly the temp falls back down. And then it gives it power again and sees how quickly it recovers. So this is what it's doing to get the information on what the PID value should do. And it's going through and automatically calculating this. So you can see here, it determines some values, it's going to apply them and try them. So now that it's got those new values, it's seeing how much power it actually needs to apply to get back up to that temp. And it goes, okay, well, let's try it again. It's going to do this 10 times, and you can do it 20 times or whatever. It doesn't really make a difference. 10 seems to be adequate. So you can see here, we were giving it 19 out of 127 in terms of the drive strength on the PWM signal going to the hot end. And now we're at 37. So it's seeing how quickly it heats up and cools down. All right, hang on. Where is... My OBS has gotten all sorts of weird lately. I gotta like reset it up. What do I think is better, Meanwhile or ATX? Just go with the Meanwhils. ATX is more of a pain in the ass, and there's no warranty on those because you're cutting up the connectors. Unless you buy like $50 worth of plugs, it's way easier and cheaper and just as good to use a Meanwhile. The only thing is usually an ATX power supply will have power factor correction, so it's a little more efficient. But me personally, I wouldn't waste time on doing an ATX, especially since most of the machines are 24 volts. Meanwhile makes power supplies for 12 and 24 volt and 36 and 5 and all sorts of values. So it's not, Meanwhiles are not just for 24 volt printers. We actually carry 12 and 24 volt Meanwhiles. So I'm just scrolling through here and you can see it's trying out different values to see where it is. And we're in another cycle again here. And you can see here, it's spitting out a PID value and it's trying them. See it trying these different values. So it's trying to guess based on the data it has what those P, I, and D values are. And if you want a more detailed explanation, I think Alex Clemis is his YouTube channel on here. He has a good explanation of P, I, and D. I can't remember the exact terminology for them, but they're different biases and drive strengths and stuff to tell how much PWM signal you need. So here we go. So we got a slightly different one this time, and that's normal. You're going to get a slightly different value every time you run it. So we're still pretty close. You can see here, these are slightly different. So let me do here, second PID from G code at 245C. And the right PID value is the one that works for your machine. So let's see if I tell this. So you can see here, this one might be more accurate because look at, we did more cycles. So it looks like we're only doing 1, 2, 3, 4, 5 or 6 cycles when we're going from the LCD, whereas we did 10. So you can see here, it's getting smoother and smoother and smoother. If I zoom in here, you can see here, you know, we're overshooting, and it's starting to flatten it out more. So there we go. So this will probably be a good value to use for this machine. There we go. I can never remember how to get out of here. This is like a plugin for Octoprint, and it's just a prettier graph. So let me set this 245 and see how the line looks. So my Hotend fan should still be at 100%. It is. I'm going to drop this down to 40 because that's what I run on this machine for ABS. If I switch over to the V20 here, you see we're still spinning. It's just slower. And what I want to see here is what it looks like once it levels out. I don't think the PC power supply is a little safer, I guess. I mean, it's only dangerous if it's plugged in So, but you can see here, so this has got a 50 watt heater in it. It gets up to temp pretty quick. So we're going up to 245 here. So you can see I told it to heat. I am going to make sure that I save this to my EEPROM, because I don't want to lose that PID value. And you can run, you know, a C20, a cycle 20, because you can see here we did actually get a little bit smoother response by doing more cycles. Now, one thing to note is this does have an MKS control board, and most of the MKS control boards have a really crappy 5-volt regulator, just like Creality had for a while there. So, but you can usually get a decent enough thermal regulation. So you can see here, we hit temp, and I'm going to let this sit here for a sec so we can just get some more data. My dog keeps pacing because she wants to go inside because there's family over. She is driving me nuts. I hate when she paces. So, all right, let's look at this. Let's see how close we are. So this may like, oh, this is like all over the place. We're within a couple of degrees, which is good. So you see this here, 245.7. What do we get down to right here? 244.53, 243.67. That's not super good, but it's not bad. It's not going to affect your prints. Let's see where we're at, because it will level out as you're sitting here printing, and it's heated. So you can see we're maintaining a pretty good temperature now. So what you want to see is within 2C. That's the most fluctuation you want to see. And it's going to vary depending on your printer setup, you know, whether you have a sock or not, your layer fan strength, your power supply quality, your board's quality. You know, it all varies based on what you got into the machine. But this is a really good result for this printer setup here. You can see here, we're probably as flat as we're going to get. So I'm not even going to mess with the PID on here because this is giving me a really good result. So the lesson here is that when thermal runaway triggers, you got to look at what led up to it if you can. If you're connected to Octoprint, you do have some, you know, time log, so to speak, to go back and look. So that's what's nice about having this logging. You can see here before I tuned it, it was all over the place. It wasn't as flat. Whereas we're getting a pretty flat line here, which is good. So I'm happy with that result. So I'll end up putting this machine back into service. I didn't see anything here that indicated that there was any physical problem. And what I mean by that is when I fired up the Octoprint instance and looked at the logs, I didn't see that the Hotend was shooting up really fast or dropping down really fast. It just looked like it was having trouble getting up to there. And that was like, oh, I just updated the firmware. I just reset my EEPROM. It probably needs a PID tune. And then I also noticed that there wasn't a sock on the block. So those two things combined is what is going to cause thermal runaway from falsely triggering. Now, if you don't see these type of signs on your machine, then you probably have an actual problem and should start looking at the machine itself and not ignoring the issue. One of the things is when I moved around the wires, if I saw any variance at all in my temperature, or if it stopped climbing when I was telling it to heat, then there was a problem somewhere in the wiring. So if I move let's say I move the wire to the right side, and all of a sudden my Hotend just stopped heating. It was going up like 3 degrees a second, so fairly quick. And let's say I moved it to the one side and just stopped. It you know, just kind of leveled off and then started dropping back down. That would indicate that I've got a bad connection somewhere or a faulty heater cartridge. Now, if my temperatures were jumping all over the place on the LCD, that would indicate that I have an issue with the thermistor, and I should check all the wiring for the thermistor. Typically, your thermistors, when you put a multimeter on there and read the resistance, they should read right around at room temperature, like 70 Fahrenheit. They should read right around 100 to 110 K ohms. If they don't, then there's an issue with the thermistor. If it's all over the place or it's just open you have an issue with the actual thermistor itself. But the main thing to start checking is, as soon as you have a problem with thermal runaway, look at what led up to it if you can. Like, I had Octoprint connected, so I had something to go back and look at to get an idea to see what was happening for that short snapshot that Octoprint had that log for, and determine what's going on. Wait, what? Oh, sorry, I was just reading chat. That guy should be banned from this channel. I don't know why he's on here. The German nerd guy. I got tired of him begging for free crap on the channels, like spamming all of our videos. He shouldn't be in here. But I digress. Anyways, so rule out the issues of the physical hot end problems or the bed even, because the same thing can happen on the bed. So if you've ruled out issues and you don't see any indicators that your temps were jumping all over the place, which would mean a thermistor problem, or your heater's not climbing up to temp, that would be stuff you want to look at. In this case, it ended up being a combination of not having the sock on my hot end to keep it insulated from that layer fan, and having the bad PID on there because I just reset the firmware. Now, I probably could have done a PID and that heater would have kept up with the layer fan if I didn't put the sock on it, but I really like having the silicone socks on it. They make the heater work less hard, and they also keep filament and crap off the block. So as you saw on that machine, there was a ton of crap on that block. So the socks are great for insulation and keeping your block clean. No one wants a dirty tip on their nozzle. And just from a printing perspective, if you got all that crud on your block that could come off during a print, you could either have a completely failed print, because if you get a significant size chunk that the nozzle hits and it loses steps or it knocks a print over, that's a failed print. Or if you have smaller stuff, it'll lead to little cosmetic imperfections on the print. So I highly recommend the silicone socks. We carry them for all the different size blocks. The V6 with the glass thermistors. If you have an E3D with the cartridge type, they sell their own type of socks that fit their block. But if you have the V6 like that one where it's got the glass type thermistor, it's not the cartridge type, we carry those in the shop. We carry the ones for the Volcano blocks with the glass type thermistor, which is also what we carry. And the ones for the Creality stock hot ends, as well as all the A-nets and everything. So there's a whole list on those, and those are referred to as like the MK8, MK9 socks. So you typically, your MK8 or MK9 style hot ends have the same block. MK10 are a completely different one. So if you have an MK10 one, like on the WAN house, those socks won't fit them. We don't carry that size because it's not a very popular size. So, are you guys trolling me? Everybody's saying hi, Don. I'm so confused. Will they fit the mosquito block? They will not. I don't know if they carry their own. But I have seen them on AliExpress for the mosquito blocks. So, but I would recommend, if Slice Engineering carries a silicone sock, I would pick it up from them. So, but that's about all there is to it. I hope you guys learned something, and this is sitting here heated, so I'll show you guys. It's looking pretty damn good. So you can see here we're within 1 degree. This is a good tune right here. I'm very happy with this. So this is like what you want to see, and like I said, if you zoom in, it looks really bad. You know, you can keep zooming in, and oh, this is all over the place. But you look at the actual numbers. Oh, we're like within 1 degree or less. You know what I mean? So just take a look at it and see. You don't want to be seeing this when you're printing. Yeah, so I don't know if they'll fit the Sidewinder X1. Let me look at that. I think that has a Volcano style hot end on it, which would mean our Volcano style blocks would fit that. Let me see, because I'm pretty sure, yeah, this has got the Volcano style. I just want to see a picture here. Oh yeah, right here. So right there, you guys see right here. So the Volcanoes would fit the X1. So the ones on our site for the Volcanoes would cover that block up very nicely. See if I can find a better, assuming it would be on this here. Let's see this guy show the block up close. Yep. Yeah, that's a volcano block, and that's the... Trying to see the other side. It looks like the thermistor goes in on the side because you can see a thermistor wire going there. But he's not showing it. But this looks like a volcano block. Yeah. Let's see here. I heard of this company. Atomi 3D. Yeah, no. If it had the cartridge type, you'd see another hole, but that's for the heater cart. So yeah. So here you go. Silicone socks for volcano hotends. I'll have to update this because these will fit that Sidewinder block here. So you can see there, these don't have the full coverage of the nozzle like this, or like the one I installed on there. And I intentionally got this because a lot of guys were having issues where when you get up into the larger sizes, the hole from the manufacturer was too small for like the 0.8s, because these tips end up getting wider at the end. So I just had them make this mold where it was open, but it still gets the sides of the nozzle. So yeah, these fit the volcano clones, and we carry, I don't know if it's like in the recommended, but we carry the those blocks and everything. So if you guys need a replacement or you want to upgrade your V6, whether it's ours, so we've got our own hot end, we've got heat breaks. This is the heater cartridge that's in the printer. We just did a tune on. And then here's the V6 socks. Like I said, we've got white and blue. There's just a difference in the manufacturer, like which ones they decided to use. But anyways, they cover the blocks. That's for the V6. And this is our hot. And you can see what I mean by the glass thermistor type. So these are the type of blocks that we carry socks for, where you've got the glass thermistor and not the cartridge. So... And then these are for the Creality machines, most of the A-nets, you can see here. And these have the cutout here. They don't cover the nozzle because there's like 3 different sizes of MK8 nozzles that you can actually get with the machine. So again, we just have this completely open. But they're really great for keeping everything insulated. And then here's the high flow nozzle kit. So this is the block with a bunch of nozzles, and then extra thermistors, and a 12 and a 24 volt heater. So we do carry these, and you can see here, there's a picture here, and you can add this stuff on right from this cart. And we also carry 12 and 24 volt heaters. And it looks like the 24s are out of stock. So I'll have to have them count that. We're doing inventory tomorrow, so that'll be fun. But we carry all this type of stuff, and more importantly, I hope you guys learned something about here. So that's about it. Why did we get rid of the Easy ABL kits? We did not get rid of the Easy ABL kits. What do you mean I got rid of them? We have them. Right here. They're still on the site. And these should definitely be in stock because we've got a ton of these. So yeah, these are still on the site. We just have the pros. We don't have the older Easy ABLs. Those were discontinued. And we now have the pros, which are a much faster sensor and easier to connect. The DIY ones, because we were clearing out old inventory of those older kits. We will not be bringing those back ever. So, but the new board for the Easy ABLs, if you guys have used the older ones, we've simplified the setup process a lot. We got a little switch here to switch the Z end stop wiring. You got a 2-pin screw terminal or the 3-pin for your Z end stop connection. 2-pin terminal for power input or the barrel jack. So you can use the AC adapter or the USB step up. And then the sensor itself is modular. And this is actually a self-test button to test the board without even having to have a sensor on it. So, and the sensors themselves, I'll show you guys here. We're running at 600 hertz sampling rate, so we're running 600 samples per second. The old ones were 100, and I still have a lot of the old ones. I'm not gonna say the old ones are terrible. So if you guys have an old one that's working, don't bother upgrading. But we had, so here And this goes for not just other competitors making these type of kits, but even the BL Touches. They have 0 shielding. Our 3.1s had the braided shielding, and the Pros have the foil and braiding on them. So there's a lot better EMI interference protection with the Pros versus the 3.1s. And, you know, you got other people selling kits. They're just using unshielded cables, which is going to introduce interference into the sensor, which is going to screw up your reading. And then on top of that, if you guys notice on here, this isn't just a simple opto IC board. We have a 3-stage power filtering here with reverse voltage protection on here. And the sensor is actually going to be pulling its power from this electrolytic cap, because this is here for reverse voltage protection. It also doubles as decoupling. So this whole circuit here makes sure that the power going to our sensor, so you can see here, power comes in, goes to the diode, comes into our filtering capacitor setup here, and then goes right to the sensor here. So there's a lot happening on this board, even though it's, you know, simple in function, but it all adds up to a really good experience. If you take these filter caps off here, the sensor accuracy does go down. So, but that's about it. I wasn't trying to turn this into a ABL sales video, but you guys asked. And apparently Griffin found the socks for the Mosquito Hotend. And that looks to be it. So they've got these. We will not be carrying these, so go ahead and order them from AliExpress. But that's not too terrible. Like, one sock, they're not cheap. I can tell you that. Like, in general, socks are not cheap. So, but if you're going to order from China, just order a 5-pack, because they are a consumable item. That's about it. So, with that being said, I hope you guys learned something here, and I hope you guys have a little more information on narrowing down if you actually have a thermal runaway condition on your machine that requires attention, or if you just need to PID tune it and insulate the block against your layer fan. So I'm going to go enjoy my Sunday. I'm going to putz around with some more machines here and hang out with some friends. And I appreciate everybody stopping by. I think we hit a peak of 91 people watching, so that's awesome. So anyways, if you guys will be able to watch this video on the replay once YouTube finished processing it. I can't talk today. Processing it. And if you guys want to support us in what we do, we don't take donations. Just buy cool stuff for your printer from our shop. And we also have like Amazon affiliate links in the description too. And I use that affiliate cash to buy fun things to show off or blow up or take apart on stream. So anyways, everybody, thanks for stopping by. And as always, happy printing. Bye-bye now.